Alright, so I need to find the second derivative is the next thing I want to do, and I'm going to try to squeeze that in right here. So I'm going to have to do it from right here. Bottom times derivative of the top minus the top times derivative of the bottom, which would be 2 and then x minus 4. All over bottom squared, which would now make that say x minus 4 to the 4th power. Now, one of the things you guys will get more used to is that you have two terms here, and when we have these huge quantities, we're not going to want to multiply this stuff all out. What we're going to want to do is look for common factors. And so I've done this in another problem where I've simplified. I'm going to take out an x minus 4 everywhere. So I'll change this to be x minus 4 to the 3rd. I'll eliminate an x minus 4 here, and I'll eliminate an x minus 4 here. I can do that because I have one term here, another term here, and then a term down below, and each of the terms have an x minus 4. So what that leaves me with is an x minus 4 times a 2x minus 8 minus, I have this 2 times this, so I have minus 2x squared minus 8x plus 12 all over x minus 4 to the 3rd power. Now it looks like this isn't going to simplify very well, but it actually does. I end up on top when I FOIL this 2x squared, a minus 8, a minus 8 is minus 16x, and a positive 32, minus 2x squared plus 8x minus 24 all over x minus 4 cubed. What happens then is my x squareds cancel. I have a mistake right here. You guys weren't there to yell at me. This should have been a 16. I knew that these were supposed to cancel. These cancel now. And then I have 32 and negative 24, which gives me an 8. 8 over x minus 4 cubed. So you see me make some mistakes here. On the bottom is my only critical number. My only critical number then is 4 for the second derivative. I called it a critical number. Possible point of inflection is what I should have been calling that. So when I test for concavity, when I plug in 5, I end up with a positive value, and when I plug in 3, I end up with a negative value. So I know where it's concave up and concave down. So I haven't done each of these things, but due to time and the amount of the length of these videos, I'm going to go ahead and start sketching this. I have a vertical asymptote at x equals 4. I have a slant asymptote at x minus 2, y equals x minus 2, so that would be here, up 1 over 1, up 1 over 1, up 1 over 1. There's my slant asymptote. And then I know that it is concave up and concave down. Is concave up over here and concave down over here. So basically I know it's going to squeeze in between these parts. I know that there's max is a max at 2 and a min here at 6, and I did not find those values. You really should find those values. You would find those values by plugging those values back in up here and plugging them in for the x portion, and that would give you, I will just go ahead and tell you, those max value is 2, negative 2, and the minimum value is 6, 6. Because of the length of these videos, please feel free to ask me the amount of any questions that you guys need to during class. And I'm not completing this last problem, but if you'd like me to do it in class, you just need to remember to ask me. So I will be happy to sketch this graph during class, so that we'll just do that one later.